Thank you very much. Please, may we be seated. Once again, we want to welcome every one of us to the 95th Inaugural Lecture of the Federal University of Agriculture, Abeokuta. The lecture is titled, Beneath the Waves, Resolving Ambiguities in the Petrologic Supermarket, to be delivered by Professor Victor Makinde. First of all, permit me to introduce the members of the procession. And that procession is being led by our Vice-Chancellor, a fellow Genetic Society of Nigeria, fellow Institute of Health and Safety, and fellow Agricultural Society of Nigeria, Professor Babatunde Kehinde. Please, a round of applause for him. Next to him is the Deputy Vice-Chancellor, Academic, Professor Oluwafemi Balogun. You're welcome, sir. We also have seated in the other side the Deputy Vice-Chancellor, Development, Professor Kola Adebayo. Also on seat, we have our Registrar, Dr. Titus Adedeji Adeniyi. You're welcome, sir. Bossa is on seat also. Let's welcome Mr. Olukayode Oshinuga. The University Librarian, Professor Abayomi Owolabi. You're welcome, sir. The Dean, College of Physical Sciences, that is the Dean of our inaugural lecturer, who also doubles as the Chairman, Committees of Deans and Directors. Please let's welcome Professor Adio Akinwale. You're welcome, sir. And the Head of Department, Physics, that is our inaugural lecturer's department, Professor Comfort Itunu Okeyode. You're welcome, ma'am. And to our lecturer of the day, who today is prepared to delve into the complexities of understanding the Earth's interior, particularly in relation to petrology, which is crucial for understanding the formation and evolution of the rocks. Please let's join hands together and welcome specially our 95th inaugural lecturer, Professor Victor Makinde, a professor of Applied Geophysics, Department of Physics in FUNAAB. We also welcome the members of family and friends of Professor Makinde, led by Mrs. Adeola Folashade Makinde. You're welcome, ma. Let us also welcome our members of procession, the deans and directors of the Federal University of Agriculture seated in the procession. Please, you're welcome, sir. You're welcome, ma. And all members of COLPHYS family here seated, we also welcome you specially to this lecture. A round of applause for yourself. To this end, permit me to invite specially the Vice-Chancellor, Professor Oluwafemi Babatunde Kehinde, for the welcome address. A round of applause for the Vice-Chancellor.
The members of the university management, that is the Deputy Vice-Chancellor Academic, DVC Development, the Registrar, the Bossa, the University Librarian, Chairman Kodat and Dean COLPHYS, Head Department of Physics, and the Inaugural Lecturer. Hold on. Other heads of departments here present, members of the University Senate, deans and directors, members of the family and friends of the Inaugural Lecturer, distinguished ladies and gentlemen, great FUNAABites, great FUNAABites. As I welcome you to this inaugural lecture, may I now invite the inaugural lecturer of today, Professor Victor Makinde, to please stand and remain standing beside me. It is my pleasure to welcome you all to the 95th edition of the inaugural lecture series at the Federal University of Agriculture, Abeokuta in Ogun State. Concerning our inaugural lecturer of today, Professor Victor Makinde, he was born to the family of Pa David and Mama Victoria Makinde. He had his elementary education at the CAC School, Olugbode, Ibadan, in Oyo State. Professor Makinde was trained as a physicist at the University of Ilorin and as a geophysicist at the Ahmadu Bello University, Zaria. He was also trained in pedagogy to become a teacher at the former Oyo State College of Education, Ilesha, which later metamorphosed to the defunct Osun State College of Education, Ilesha, and now University of Ilesha. Our lecturer of today was certified a professional teacher by the Teachers Registration Council of Nigeria at the defunct Federal College of Education, Zaria, now Federal University of Education in Zaria, where he worked for several years. He served as facilitator and instructor at the Nigeria Teachers Institute, Kaduna, and in Abeokuta. He had trainings in other areas of human endeavor before eventually settling into teaching. His work experience. Professor Victor Makinde joined the services of the University of Agriculture, Abeokuta in 2006 and has served in various committees and capacities at departmental, college, and university levels. He was the deputy dean, later became the acting dean, and now again is the deputy dean of College of Physical Sciences. Professor Makinde has to his credit more than 79 articles in the area of geophysics and over 30 in pedagogy / science education. And he has supervised more than 120 students at undergraduate level, more than 21 at the Master of Science level, and 11 at PhD level. Professor Victor Makinde is married and blessed with children. Distinguished ladies and gentlemen, it is my pleasure to invite Professor Victor Makinde from the Department of
my Lord spiritual and temporal, gentlemen of the press, distinguished ladies and gentlemen, great FUNAABites. In the name of the Creator of the universe and God of abundance, I welcome every one of us to this 95th inaugural lecture titled Beneath the Waves, Resolving Ambiguities in the Petrologic Supermarket. This lecture is from the Department of Physics, and physics thrives on the strength of imagination, mathematics, and computation. Definitely, this will not be lacking today. Generally, methods of geophysics extract information about the subsurface through interaction of relevant waves with matter and materials of the subsurface. Mr. Vice-Chancellor, kindly allow me to give some definitions. Waves, what are waves? Waves generally are pulses at regular or irregular intervals, transferring energy from one point to another along a wave train. Waves generally are of the form y is equal to ym sine theta, where y is the amplitude of the wave. And a wave field is observed on a plane, that is the surface of the earth, and the goal is to create a 2- or 3-dimensional model of the scattering objects to one side of the plane. That side is beneath the plane. A supermarket is a general warehouse or superstore or large shop through which goods are sold out. There people choose what they want from the shelves and pay for it as they leave. The evergreen book of life states that in 2 Timothy chapter 2, verse 20, but in a great house there are many vessels, some to honor and some to dishonor. The same is applicable to the supermarket of interest today. An ambiguity is a situation of being open to more than one interpretation. And to resolve ambiguity means to find unique solution to an otherwise ambivalent situation. Petrology, another word there, is the scientific study of rocks. The universe was formed about 13.8 billion years ago, and it comprised of galaxies, one of which is the galaxy in which we are, which is the Milky Way galaxy. There are many other galaxies. Andromeda is there, Antenna is there, Backward is there, Black Eye is there, Bolt is there. There are so many of them. Our own galaxy is the Milky Way galaxy, and galaxies also comprise of solar systems. Each of the solar systems has planets within it. Our own solar system is one of the 3,916 of such within the Milky Way galaxies, having about 5,241 exoplanets. Our solar system is located in the Orion arm of the Milky Way galaxy and has within it about 8 planets, of which our home, the Earth, is one. The universe is expanding at a rate of, which is known as the Hubble constant. The Milky Way galaxy is moving at a rate of 12.1 million kilometers per hour. The Earth, which is oblate, spheroid in shape, which was formed about 4.6 billion years ago, with a polar radius of 6357 kilometers and equatorial radius of 6378 kilometers, revolve around the sun in elliptical orbit through an orbital distance of about 940 million kilometers at a rate of 30 kilometers per second in 365.2 days. The Earth also completes its motion from west to east so that it appears as if the sun rises in the east and sets in the west. The axis of rotation of the Earth is at an angle of 23.5 degrees to the vertical. This angle influences temperature changes and other weather patterns from season to season. The Earth is located at about 150 million kilometers from the sun. That distance is what we call 1 astronomical unit. It is therefore obvious that the creator of the universe made just one universe, tens of galaxies, thousands of solar systems, billions of planets, yet one abode for human life in this form that we have it. That means the Earth, which is also called the blue marble, must be a special place of interest to its creator, the owner of the universe. The Earth is viewed as an operational system of interacting spheres. These spheres include the geosphere, the atmosphere, the hydrosphere, the cryosphere, and the biosphere. All these move together as one entity, which are bound together to the solid center by gravitational forces. The structure of the Earth, like the structure of an egg, is divided into three. These are the crust, which is divided into two, one as the continental and the second as the oceanic crust. We also have the mantle, which is also subdivided into two, upper and lower mantle, and we have the core, which is divided into outer and inner core. The three of them are called the trinity of the Earth structure. There are 5 discontinuities within the Earth structure. These are the Conrad discontinuity, the Mohorovičić discontinuity, the Repetile discontinuity, Gutenberg discontinuity, and Lehman discontinuity. Each of these continuities describe a point or position within the Earth structure. The crust is covered by a series of constantly moving tectonic plates. There are about 12 tectonic plates, major tectonic plates, which include Antarctica, Africa, Eurasia, and so on and so forth, and several other minor plates, such as Scotia, Caribbean, Juan de Fuca, and so on. We will recall that the Madagascar plates and the India plates broke away from the African plates, and that we are still expecting that another plate will come through the East African side and break away not too long from now. Tectonic activities such as subduction and faulting has shaped the crust into a variety of landscapes. Earth's highest point, Mount Everest in Nepal, which soars about 8,850 kilometers in the Himalayan mountains, is one of them. Mount Everest continues to grow every year as subduction drives the Indo-Australian tectonic plate below the Eurasian tectonic plate. Subduction also creates as deepest point the Mariana Trench, about 11 kilometers below the surface of the Pacific Ocean. The heavy Pacific plate is being subdued or subducted beneath the small Mariana plate. And we also know what is happening within the coasts of countries like Iceland. The Earth's physical environment is often described in terms of the spheres. The magnetosphere, which is this pocket or space surrounding our planet where charged particles are controlled by Earth's magnetic field. We also have the atmosphere, which is a blanket of gases enveloping Earth and retained by our planet's gravity, which from ground towards the sky are layered as the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The hydrosphere, composed of all the waters on Earth, and the lithosphere is the Earth's solid shell. Almost all materials on Earth are constantly being recycled. The three most common cycles are the water cycle, the carbon cycle, and the rock cycle. Earth's history is divided into time periods. Just like you have days, years, months, days, hours, seconds, and whatever. The longest time period in the Earth's history is the super eon, and only applies to one unit of time, the Precambrian. Eons, eras, and periods are smaller units of geologic time. Right now, we live in the Phanerozoic eon and the Cenozoic era, which began about 65 million years. We live in the most recent period, the Quaternary, which is then broken down into two epochs, the current Holocene and the previous Pleistocene, which ended about 11,700 years ago. We want to look briefly at the origin of geophysics. The art of geophysics started from its use in the military to discern how far or close enemy forces are from one's location. Then it was done by putting one's ears to the ground and picking the signals through wave motion within the earth structure. This is seismics in geophysics. Another common use was in estimating how deep or shallow a pool of water is by observing the spacing of the wavelet crest as the wave propagates through the water when a small pebble is dropped into the body of water. This is basic physics technique of wave propagation. Geophysics is a diverse science and a very plastic discipline. At its best, it has the rigor of physics and the vigor of geology. It stands on the analytics of mathematics, power of computation, and we have support from electronics. In simple terms, geophysics is the application of physics principles to solving geological problems. Geophysics, in the broadest sense, is the science or application of physics to investigations of the Earth, Moon, and planets. Generally, geophysics contains all this and the subject of astronomy. Geophysics means different things to different people. For the Nepalese, Californians, Icelanders, it is earthquakes and volcanic eruptions. For Chinese and Americans, it is sinkholes. For people of Texas, Alberta, Niger Delta, it is oil exploration. For Russians, it is permafrost and gas exploration. It could also mean some other things to you. But what you know is that geophysics is one discipline, many applications and different techniques. In essence, geophysics enables us to make remote insights into the Earth's subsurface for different reasons and focus. Geophysics find application in areas such as engineering, environmental, archaeo, bio, forensic, glacial, hydro, and agro. All these fields also overlap. There's no one particular method for anyone. But because it is a kind of experimental work, whenever you get somewhere and you find a method to be applicable, you use that method. All the basic principles and laws of physics find application in geophysics, and it is evidenced in gravity, seismic, electric method, and so on and so forth. Because there is really a unique geophysical solution, then to ensure success, every geophysical survey must be conducted within an appropriate geological framework. And that is why we always tie the geology of an area to the interpretation that we are going to make after getting or collecting the geophysical data. The objectives of geophysics or geophysical survey are to remotely map changes in subsurface geology and hydrogeologic conditions, to recognize and map economic resources, to tie geophysical information to the geology of the area, and therefore optimize locations for exploration, exploitation, and for drilling wells. Contribution to knowledge. I want to mention just 3 areas. We have so many, but we will pinpoint these 3. First is the self-potential method, which is a natural electrochemical geophysical method in which electrochemical processes cause all bodies to act as batteries. The separate but simultaneous reduction of oxidation of oxidizing agents near the surface and the oxidation of reducing agents at depths causes electric current to flow. The ore body itself, however, only serves as a conductor, transferring electrons from the reducing agents to the oxidizing agents. It does not in any way participate directly in either reaction. In order for the above reaction to occur, there must be in existence differences in oxidation potential of groundwater at different depths, thus causing the surface of the area over the top of the ore body to have a negative potential with respect to the surrounding area. By this process, the self-potential method can be considered an electrical method. The figures we have show the ore body, the sulfide body, and the circulation around such a body when SP, self-potential, is being exhibited. This other body shows the method of taking measurements on the surface of such an ore body. We can see a voltmeter there, making sure, telling us that we consider this as an electrical method. However, in 1987, Makinde considered the SP problem as a dipole problem and therefore approached it from the perspective of basic physics. In deriving the expression for the thick dipe SP anomaly, some vital assumptions were made. We clearly specify the conditions under which the expression and its derivative remain valid. The assumptions are as listed. We started with the equation, the basic electrostatic equation of the electrostatic potential at any distance out from any charge Q, and that is equation 1 that we have there. If we assume the buried source to be an electric dipole, having two equal and opposite charges, minus Q and plus Q, place R1 and R2 distance from the field point, the law of summation yields the value for the potential V at the field point as what we have in equation 2. Going through all the parameters, we eat up all those ones, and we are able to arrive at equation 3. From equation 3, we go on to get the three-dimensional expression for this potential V, and is given by equation 4, which represents the general spontaneous polarization potential. We now want to limit it to a 2D source, and the potential given in equation 4 is now reduced to a two-dimensional equation of equation 5. This equation fully takes into consideration the capital P, which is the dipole moment per unit volume, which is also called the electric polarization. The figures that we have show the parameters of the SP line and the parameters of the model which we want to use. In geophysics, we use different kinds of models. You use line, cylinder, laminar, sphere, and so on and so forth. One of them is the dipping dike. We have the thick dipping dike, we have the thin dipping dike. And it could also not be dipping, it could be straight, as you like it. Figure 4 shows the thick dipping dike with all its parameters defined. We did a lot of running through the mill of the equations, and we were able to arrive at equation 6. Equation 6 has a big Z in there, and the value or the expression for that big Z is given in the big brackets which we have. And your capital M is equal to capital H minus small h called delta, where small h is the depth from the surface of the ground to the surface of the dike. And capital H is the depth from the surface to the base of that dike. We also derive the horizontal gradient, which is the differentiation of the potential to give us that equation. I think it should be equation 7. Sorry for labeling it wrongly. These equations, V and Vx, can therefore be used to model self-potential method as they transform the self-polarization potential from being an electrical method to being a potential theory method. Under normal circumstances, if we are correct, we should have these two shapes. The first one for the expected anomaly profile and the second one for the expected horizontal gradient profile. And here we go. After modeling, we got these kinds of graphs. And looking at them shows that we are quite in line with the expected or the standard that was expected. In order to interpret this, we decided to normalize the values of x, b, and h. And we normalize it using small h. We have x over h from 0 to whatever, b over h from 0 to 0.5 to whatever, and your capital H from, actually we took it from 2 and so on and so forth, with our delta being from 30 to about 150 degrees. All these other ones show the relationship, the trig values, the trig relationship or angles of. We use this figure to do as the monograph to interpret these anomalies. Reduction to thin dike. If these equations were correct, we should be able to get the thin dike outside from it. There are some things we normally do to reduce one to the other. It is by collapsing R1 to R2, R3 to R4, and Phi1 to Phi2, Phi3 to Phi4. And after doing all those things, we got this equation, which is labeled 6. By this finally validates the expression for the thick dipping dike as a potential method rather than as an electrical method. The third, which I want to mention, is the development of a variant of the second is the development of a variant of the two electrode system. There are different forms of the two electrode systems, and most especially what we use around is the 4 electrode systems. In deriving this, we make some basic assumptions, and the assumptions are as listed. We base the theory and the development of this theory on 2 models, the hemispherical model and the near-spherical bowl as models for our development. And we were able to get some equations through, just pick some. In modeling resistivity methods in the lab, we need to use suitable conducting materials which permit the flow of electric current as the layer medium. Geological structures are usually simulated by small-scale models of a size small enough to be readily handled in the lab. When you are developing a new method, you first do the laboratory test, you then go to the field. In a situation whereby the medium itself is being investigated, the real Earth situation is suitably configured using suitable scaled homogeneous isotropic electrolytes and earth materials. The tank which we have there is the tank we use for the laboratory investigation. This tank was first used by Professor S.B. Ojo, I think when I was still in primary or secondary school, to model seismic experiments in the geophysics laboratory of Ahmadu Bello University. When I got in there, I had to modify or to strengthen this, to fortify this tank, because the earth materials which I was going to use were quite different. And experiments were therefore conducted to determine the operating frequency of the tank, the scaling factor of the tank, capacitive coupling effect of the tank, and the tank characteristics over some earth materials. You have to take some precautions. And in order to do that, we did the tank wall effect and the bottom wall effect. I also took control experiments using conductivity meter and meter bridge experiment to gauge and to get the true values of the earth materials which we were going to use. I learned a lot from Professor S.B. Ojo, who later became the chair professor at OAU Ife, on how to conduct most of these experiments. And we were able to get this out. The first diagram we have here is the relative position of electrodes with respect to the tank walls in modeling the winner within the 4 electrodes within this tank. We also did the same for the 2 electrodes. The graph we have on the right shows the value as resistivity against A over Z for investigating the effect of the bottom of the tank wall for the 2 electrode system. The figures we have here shows the resistivity against frequency for investigation between the sidewall tank wall effect for the 4 electrode, and the one to the right is for the 2 electrode. For the 4 electrodes, we use A equals 4, 2 centimeters, 5 centimeters, 10 centimeters, and for the other one, we used L equals 2 centimeters, L equals 5 centimeters, and L equals 10 centimeters in order to obtain all this. We then did 2 and 3 layer out modeling of this experiment. I have said earlier on, the base of the motor tank served as the electrical basement. We emplaced some homogeneous and isotropic earth materials, namely river sand, laterite clay, and some others, to form 1, 2, and 3 layer overburden over the Passcode basement. Equation 1 that we have here was pulled from the book of Geophysics by Keller and Frischner, 1966, which gave the relationship between resistivity and depth for any earth material. We had to use this equation because we need to plot these graphs. And therefore, we went ahead to get equation 2, which shows that the kind of graph we can draw for this is a log linear graph. And this equation is of the form y equals mx plus c, meaning that if we plot our graphs and we are not able to get linear relationships, then something must be wrong with us or with the experiment as we use the semi-log paper. For the multi-layers, this is the kind of graph we have. And for the 2 layer, which is a single layer overburden, this is the kind of graph we got on the right-hand side. If we have more than 2 layers, 3 layers, that is 2 layer overburden and so on, we should have segmentation. We know why this is this, because this is a homogeneous material and placed over the basement. When we went ahead to get 2 layer overburden, we have this segmentation. And from here, we can see that we have 3 segments on the left. And for the 4 layer case, where we have 3 layer overburden, we have 4 layers on the right-hand side here. We also went ahead to determine the ability of the 2 electrode variants to delineate vertical contacts. That is to run horizontal profiling. And we made an arrangement where a block of laterite clay, which is low in resistivity, was sandwiched between 2 blocks of river sand, which were high in resistivity. And we profiled with the 4E method and the 2E method. The result of the horizontal profiling for both of them showed that the 2E variant delineated the different portions as much as the 4E variant did. And therefore, we were able to achieve that the 2E variant promised to be a good substitute for the 4E Werner array or 4E variant in use for horizontal profiling. This is the diagram we have, and we can see the corresponding positions of this. After this, we went to the field. In ABU, we have many field areas where we test our new methods and our equipment. The field investigation was kick-started at the Jamal Kubani village borehole. There is a borehole there which was drilled by Messrs. Preside, Nigeria Limited. The borehole is well logged and highly productive. This borehole has 4 layers, as we can see the profile or the borehole log as we have it in the diagram. Mr. Vice-Chancellor, sir, over there in the north, they ensure that their boreholes are logged. But down here in the south, we had tried to use many boreholes, but we found out that boreholes here are never logged. Even organizations that we expected will always log their boreholes do not log it. Logging boreholes help us as researchers to be able to do a lot of things within an area where we find ourselves. We make calculations around the periphery of data obtained around the periphery of the borehole. So also we went to inside the village, away from the borehole, and these are the kinds of calculations that we were able to come up with. We can see good correlation between the 2 methods, the 4E and the 2E. And again, going back to the borehole site with the 2E, we got 4 layers as we have it there, but in other parts of Jamal Kubani village, we got 3 layers. This is consistent with what we have been getting with 4E methods. Further investigations on the viability of this variant was undertaken in comparison with other methods. In projects that we undertook for PTDF in Kogi East and the FCT under the Abuja Master Plan project, the results obtained were highly encouraging and confirmed that the variant to be successful and settled. Other investigators, such as Yusuf and Umego, 2014, Bachama et al., 2017, amongst others, had put the methods to test and found it comfortably conformable. Bachama et al. In 2017 commented that this variant of the 2-electrode array, which was christened by ABU to be the Ajayi Makinde 2-electrode array, had proved to be effective as a new geoelectric prospecting method. In the words of Yusuf and Umego 2014, the method has high depth of penetration, delineated accurately the subsurface layer, and was easy to handle in the field. The method was found to be effective and highly successful. Mr. Vice-Chancellor, sir, the patent of this method was done in the year 2001. The third method, which I want to mention now because of time, I will not go to many other ones, is the method when I say we, the supervisory team and the students, myself, Professor Mustafa, developed, and the student, then Mr. Koka, for his PhD, we developed the technique of delineating geologic boundaries using radiometric method by applying radiometric surveys to delineate between sedimentary terrain and basement complex along Abeokuta Shagamu Road. In there, we use small spacing, and we use handheld radiometric equipment between the governor's office and police college. We were able to delineate the area where we have the transition zone between the basement and the sedimentary. Beyond that, we started using large spacings to be able to know whether around somewhere there will be another discontinuity. This is the geological map of the area. This is the kind of data we got, and we were able when we treated this data, we were able to determine where the transition zone starts and where it ends along the Abeokuta-Shagamu Road. More work has been done by other people using this same method. I know for sure that the illumination of your candle light does not glow or light your space better by putting off the lamps of others or depriving them. It only does by putting light on the lamps of others. The more of them you light, the better the illumination of your space. Without lighting the candles of my students, definitely I will not be where I am today. I thank my students for giving me the opportunity to light their lamps. Mr. Vice-Chancellor, sir, at this juncture, I want to highlight few of the work of interest which I did with some of my students. I have in mind that time is moving and we have to quickly move. I have many of them listed here, but I will just pick few of them. One of the very first basic things that we know that people suffer from is how to get water. And groundwater investigation is one of the basic things that every student that comes into physics department of geophysics should first of all be able to do. Water is an essential commodity. A lot of people spend a lot of money on drilling boreholes. In a typical well or borehole that people drill around, we know that the flow rate is variable. So also is the water quality and quantity. The yield is usually intermittent or seasonal. It's not sustainable throughout the season. And the well is usually of medium to high depth. However, in an ideal well, we expect that the flow rate will be high. The water quality and quantity will be good. The yield will be sustainable throughout season. And the well will not necessarily be too deep. Or if you are able to get the right place, it could even be much lesser than what others may be drilling elsewhere. If we look at this diagram, we can see some boreholes that are drilled. You can see borehole number 1. Someone comes there to drill a hole for you, and immediately, not too deep from the surface, he gets water, and everyone shouts, "Eureka, we have found it." And after pumping about 2 tanks, the water was no more there. What does it mean? It means that that borehole has been drilled on shallow bed aquifer, and there will be discontinuous flow rates. Number 2 also showed deep aquifer, which is only recharged on seasonal basis. During the rainy season, there is abundance of water. But during the dry season, nothing to show for it. You want to drill another one or to redevelop that hole. 3 gives us a bedrock aquifer where you have sustainable yield, but you may have low flow rate. But the best one is the one of 3, 4, or 4, where you are able to reach the fractured zone and you hit the bedrock aquifer, you have sustainable yield and high flow rate throughout the year. That is the kind of boreholes that students in geophysics in this university are being taught to drill, and they have been drilling successfully. And I can show you, when by the time I start calling them, I will show you the experts, one of the experts, and to which other people have joined. And we have 100% success rate in their ability to drill correct boreholes, which has sustainable year and high flow rate throughout the year. That is the kind of students that Federal University of Agriculture is training. We quickly went to Okebadon Estate, and we tried to, they had problems of groundwater in there, and we did investigation there. We found out that about 25% of the study area have poor groundwater potential. And we also found out that they were doing white cat drilling, and along the line, they were unable to get anything. The study advised that white cat drilling should be avoided as the possibility of borehole failure in this area is very high. We have the kind of VES course for 3-layer and 4-layer that we have in there, and we have the aquifer maps and so on. All this we use to interpret where you will be able to get good water and where you will not get anything without wasting your money on drilling boreholes. Adeleke et al. 2015 addressed issues related to groundwater resource investigation in other local government area. Results showed that about 11% of the rainfall infiltrated the aquifer in other local government area. 73% was lost to evapotranspiration, and 16% ended up as runoff. Definitely, there will be problem of water in other local government. And we could see that before rain fell about 2 days ago, it fell again about 7 days ago. And between that 7 days and 3 days ago, the atmosphere was already becoming unbearable due to loss of water to evapotranspiration. Ishola et al. 2016 also carried out aquifer protection studies and groundwater vulnerability assessment in Abeokuta South local government area. And it showed calculations of the Daza root parameters show that the aquifers are characterized by high traverse resistance and low longitudinal conductance. I now try to delineate the lithology thickness and elemental compositions and quality of the phosphate rock deposits in Oshosun, Ifo. And we were able to discover that the PR deposit has appreciable amount of clay, which is an attribute of sedimentary phosphate rock deposit. The PR deposit is of low economic value because of its low P2O5 content. Adeleke also in 2022 investigated the Ogun phosphate rock at Ojaodon, and we were able to find that the Ogun phosphate rock has high potential of being used as feedstock for fertilizer and phosphoric acid production because of its high content of P2O5, suggesting that the deposit is of high economic value. Aluko in 2021 investigated activities of artisanal or small-scale miners in Okeogun area of Oyo State. We saw a lot of problems held in that area in order to be able to pick samples and to be able to take readings on the field. However, we were lucky that the student was not kidnapped. Results obtained from the field identified mineral deposits and negative environmental impacts of mining activities in the study area. They were able to degrade the area because the activities were not properly monitored by government. Jegede in 2019 also evaluated analyzed the radionuclide and heavy metal concentration in pit soils of selected quarries in Abeokuta. They bring rock to us to build our houses and so on. The study that revealed that the health risks associated with the heavy metal content of quarry soil were low, while the radionuclide concentrations were relatively high. And the use of pit soil in building constructions should be done with caution. The implication of this is that the gravels, granite, and soils being used in building construction should be well tested for radioactive materials. We have people in the departments, Professor Mustafa, Professor Okeyode, they are well versed in that area, they can help us. Government or relevant agencies will also need to certify the safety of quarry materials for use in building. I gave them an expression of what happened in a village where there is a large expanse of open rock, where people spread their whatever and they go and relax there in the evening, in the cool of the evening. And what did we find about that village? We found that they were dying young. And people were refusing to marry from that area when investigations were carried out. We found out that the radionuclear concentration of that rock was very high. The people in that village were evacuated, and ever since, there have been very low reports of early death. We should therefore be careful. Ogunkoya in 2019 investigated the existence and quality of iron ore deposits at Gbede village, and the study identified that deposit and offered geologic information about the iron ore deposits in Gbede. This was followed up by Adewumi in 2023, who also carried out detailed analysis and interpretation of airborne and gravity data of the same area. And the study revealed that where the iron deposit is of good, high economic value. It is clear that engineering and environmental geophysics are becoming increasingly important in the management of our environment. It is also good that we know that it is dangerous to build near sources of contaminants, such as dump sites and factories, giving out effluent. The groundwater system will be impaired, no matter how long it will take, except if the source of contamination is cut off. It also happens in areas where there are petrol tanks that are leaking. People see the oil, petrol, and feel it, taste it, smell it in their water. And that means that must have been contaminated. We looked at subsurface characterization. We were in Shagamu to do that, and we discovered that presence of clay is inimical to foundation health. We also checked what happens around the axis of PG School to Colon Phase 2, where you have subsurface to identify dampness on the footwalls of some of the buildings. We found out that buildings in this area will continue to experience dampness because of the high level of the water table. Some years back, we did a combined geophysical and geotechnical investigation of a then proposed lecture theater at this university. And we mimicked the subsurface using electrical resistivity imaging and soil analysis techniques. This is the outline of the study area as we did it. And Mr. Vice-Chancellor, sir, we were able to find out that the area where we studied showed that the competence of the subsoil surface is not in doubt. That the building that will be eventually built on that land at that time will therefore be safe, healthy, and in good standing. May I therefore, Mr. Vice-Chancellor, sir, ladies and gentlemen, that from the conclusion from the integrated results that the subsoil on which the lecture theatre structure is sited within the study area is safe and fairly competent for engineering work. Here we are today in the same building that was erected on that geophysically surveyed area, the Professor Oluwafemi Balogun Lecture Theatre. Confidently, we can say that this building is in good standing. I want to quickly take immediate, why do you need to embrace geophysics? I took this split shot of a bungalow somewhere, and you could see the cracks coming up from it. This kind of occurrence is not respecter of any building, be bungalow or high rise. We have to be careful that our building does not sit on incompetent layer, clay, or a near surface aquifer. There is another case of a 3-story student hostel building built in 1975. And what did we find out? This is the building. I may not be able to tell you where I picked it for, but those who know the place, they will tell us. This is the outline of the study site. Drawn profiles all around it. Resistivity inversion models of the profiles are what are shown next. And we can see what is happening underneath the building. We also, I did not carry it out. The seismic refraction tomography was also carried out along the profiles L7 and L8 for the confirmation of the result. It was in 1990 that we first discovered that this building was sinking, and the Department of Physics, Geophysics Unit of ABU decided in year 2000 to 2011 to undertake a survey of this building. Basically, what are the things that caused the problem of this building? One, uneven settlement of the building. Two, presence of clay materials in the subsurface. And three, effluent of lavatory materials from the toilets and whatever seeping into the underground. Eventually, the building had to give way. And that means government and the rich, they also cry when this kind of thing happens. But look at this lecture theater. I took it also from a very big university, a former college of education now turned into a university. This lecture theater was built around 1975 also. And what was the first thing that they first saw? They saw that the pavement and the inner floor of the building were breaking up and giving way. And they discovered that water was also coming out. They had to make a remediation of this. That means when you are able to observe in good time, remediation could be made, and therefore your system could be saved. They drilled a hole into that, and one thing I found out that the borehole was doing, it was bringing out water almost throughout the year. And when the volume of water was low, we knew that that year there may likely be scarcity of water. So it helps in remediation and in drought monitoring. Mr. Vice-Chancellor, sir, we can therefore conclude that whoever wants to build, it is wise. Whether government asks you to do geophysical survey or not, it is good you do it for your own good. It will help you to manage the land where you have. It will help you to know where to position everything. You will not position your well and your septic tank where the aquifer is. If you make that mistake, you can be sure you cannot live in that house. You will be able to manage your land appropriately and place everything in the right place. I have some suggestions for government. There are quite many, but I will say that many activities in this country should be highly regulated. There should be more water projects executed for communities, not presently served by municipal pipe-borne water. Drilling of boreholes should be regulated to avert future disasters. Geophysics is becoming a good ground for providing mass employment. It should be made attractive to the young ones. I also have some suggestions for this university. This university should be proud of our geophysics program as taught at postgraduate level in the physics department. We also have seasoned young geophysicists in the department who will form the backbone of development of this institution. Geophysics equipment are pretty expensive. We don't have equipment. There should be standard training equipment for geophysics department. Geophysics unit should be incorporated into the physical development team of the university so that they can work hand in hand. First of all, do geophysical survey and then work with sister departments in other departments to handle the geotechnical aspect and to deliver long-lasting infrastructure in this university. The Vice-Chancellor, sir, I will not go without asking and joining others to request for the setting up of the College of Art Sciences in this university. That college will house the departments of geology, geophysics, geochemistry, meteorology, marine science and technology, remote sensing and geoinformation science. This is the normal practice all over the country now. Moreover, this university is equally overripe for expansion and yearning for the setting up of some other departments, such as building, computer engineering, biomedical engineering, medical physics, physics with electronics, to mention but a few. This environment is green. I want the university to protect this green environment from staff and students who cross the lawn at will without remorse. Know that beautifully cool environment is good for training of people. I think this campus is too much open to the scorching sun. We have been to universities where we studied and in some other places where trees are well and properly patterned to protect the environment. This should be encouraged to strategically plant some more trees over here. I want to acknowledge and thank the following people. I want to first of all thank my beautiful, disciplined parents. They were friends and they held us tight, myself and my siblings, and other people who live with us, like the sun held to the planets, under rule and good behavior and conduct. I pray that their souls will rest in perfect peace. I also want to thank my siblings for being great friends and being good examples to me. I was the last among them. I pray that their souls will also rest in perfect peace. I wish to acknowledge all my teachers from primary to tertiary level. Mr. Bamiduro cannot be forgotten. I was a very small boy, and each time I heard his voice from my sleep, they said I would cry out, and then I would stand up, and the man would pick me and take me to his office. And that was how I got enrolled in school. I thank him very much. May his soul rest in perfect peace. I thank all my secondary school teachers who also drove senses into my brain when I was going astray. I thank them. It was terrible at that time. I felt like they were disciplining me unjustly, but later I got to know they were trying to correct me. I want to appreciate the man who brought me into geophysics. I call him Professor at Large, Professor P.C. Pan. I wouldn't know, I was unable to decipher where he came from because I knew that he was in the US for a long time. He was in Mexico, he was in Argentina, he was in Canada, he was almost all over the world. East, West, he was in Australia before coming to Nigeria. And I was the last student he supervised. But I started working for him when I was an undergraduate. When they were working on the Gurara Water Project, I was with him. He called for me from Professor Chike Obi, and that was how I got to know him. And I want to thank him. I thank Professor Aro, who admitted me to Uni-Ilorin. My HOD is Professor Bamigoye, deceased, the former VC of Uni-Ilorin, Professor Yiloye. I thank Professor Balogun Ceremonial the Professor Fletcher, the former DG of Ghana Atomic Energy Agency, and all the other people. Professor Ajay, Professor S.B. Ojo, ABU, Professor I.B. Osazua, my very good great friend, Professor Marius Nnanna Umego. I want to thank all of them. I also appreciate all these other people, Professor Alagbe, Professor Jimba. They really helped me a lot. Sisi Akpa, DIM 1, DIM 2. DIM 1 was the dangerous victor in physics department, and DIM 2 was the former dean of College of Agriculture. IOB Ewa was the former minister for science and technology. I thank all of them and all my other friends. I want to specifically thank my other daddy, one of my uncles. My parents handed me over to them when I was still very young. Daddy Abraham Ogugbile and their mother. I also want to thank my daddy, Daddy Aremo. They call him Abeokuta. I want to appreciate all my friends, the ones we went to school together in the flying school, the one we went to school together at the... Yes. I want to thank General Adeshison and Ipe here. We met at the military school. Professor Dr. Matemilola from Owu Kingdom, I want to thank him. The Olanloyes, Macaulay's, Ajogbejes, and every other person. I'm so grateful for being with me. And I want to thank my students. One, I want to thank Professor J. Opoka. If he's here, he was my first student when I came here. I supervised his MSc and his PhD. He's now a professor at Olabisi Onabanjo University, and is the current president of the Nigeria Institute of Physics. Professor Koka, if you are here, can I see you? Okay. They are having their accreditation right now. So he told me he might not be able to come. Dr. Eseo Ishola, I mentioned his name, one of the very good students who did everything heart to heart. Dr. Ishola, if you are here, can I see your hand up? I saw you earlier on. Dr. Ishola, you are welcome. Thank you very much. Very hardworking person. Dr. T.J. Aluko, if you are here, can you show yourself? Okay, Dr. Aluko, thank you very much. You are welcome. Dr. Adeleke is in the UK. After taking his PhD, he went off. Femi Adewumi too is over there. Charles Ogunkoya, I saw you when I was coming in. Thank you very much, Dr. Charles. Dr. Aiguele, I wanted to read the work of Aiguele. He graduated, he did his, what do they call it, at the PG school on November 1. So I wanted to mention his name, but I had, because of time, I couldn't. Dr. Sheyi Jagede, you are just back from South Africa, and you are around. I saw you before I came in. Are you there? Thank you, Dr. Sheyi Jagede. Dr. Oladejo is in Liberia. So I wouldn't, but he called me before I came in. Dr. Aziz Edunjobi, you are here. I took his, I supervised him at first degree. I was one in the supervisory team at second degree and final PhD degree. He's the expert, 100% success in borehole drilling. Dr. Aziz Edujobi, thank you very much. You are welcome. Keep the flag flying and represent FUNAAB very well. Johnson, I know is in the US. Osita Eyawu, I saw him before when I was coming. Agbola Yobami is in the UK. All of them, I have so many of them all over there. And we continue to discuss. I want to thank the Babatundes, the Onifades, for hosting us when we first came here. We had no place to stay. They were the first to take us in. Thank you very much, the Babatundes and the Onifades. I thank my head of department, Professor Itunu Comfort Okeyode. She's one of the very first people who bears the same name in 2 languages. In Yoruba, it is Itunu. In English, it is Comfort. Very pleasant languages. May you live long and in good health and in abundance. We are proud of you. Yes. I thank all my colleagues also in the physics department. The names are there on the screen. I thank my former HODs, Professors G.A. Adebayo, B.S. Badmos, and the current DVCA, Professor Akinyemi, very good people, nice people. All the 4 men or 16 valves of physics department, I thank you. Dr. Adebambo, Egunjobi, Ajayi, Dr. Kinlami, Dr. Olurin, and Dr. Ganiyu. Dr. Ganiyu, I normally call him Abduji because one of my organs in the Emir's Palace in Zaria used to call me Abduvi. So I decided to call him Abduji. So Abduji, thank you very much. I want to thank the technical staff and everybody and all the people that helped me to be. We worked together, we supervised together, we also wrote papers together. I will not forget to thank all the pastors, my friends, Professor Sherif Adewi, all other friends from all faiths. I thank you. I want to thank members of my church in Zaria, Calvary Baptist Church. That was the church that trained me and built me up spiritually. And now I thank members of CAC Agbala Ituraban Toko. I also thank all members of Bible Society of Nigeria. And I want to specially thank the Vice-Chancellor for giving me the opportunity. The Vice-Chancellor and his management team for the good work they are doing and for the opportunity given to me to make this presentation. The Vice-Chancellor will permit me to thank my dean and those people. My dean, gentleman, man of his own words, who encouraged me to take up this opportunity to give this talk. Thank you very much, sir. I will forever be grateful. I also thank Professor Mustafa, my very good friend. We have been together since when I joined for the master's program or PhD program at ABU. He also came in from service to start his own program at ABU. Since then, we had been together. Thank you very much, Professor Mustafa. I was in his office all the time. They were calling me up and down. I was cooling down there. My very good friend. I'm very grateful. Please, I want to give my respect to all my departed friends. Principal among whom are Dr. John Adigun. John Adigun died very early in the year 2003. It was a very big blow to me. When they see John, they will say, "Where is Victor?" When they see Victor, they will say, where is John? So it was a big loss to me. 6th of January, 2003, I think so. May his soul rest in peace. Albert Yozua, well, circumstances, he died on the same day in the same accident with his wife on Abuja Road. May his soul rest in perfect peace. Shagun Odeleke, Oyedeji, Professor Femi Onifade, Professor Dekunle was first my special advisor before he became special advisor to the then General Dia. May his soul rest in perfect peace. Professor Keleye, Professor Ladokun, and all the rest of them, we all know them. May their souls rest in peace. I want to thank Nigeria for giving me the opportunity to study in this country and for the tuition-free education that we enjoy. Well, I know that Walter Rodney wrote on how Europe underdeveloped Africa, but I know from everything, I don't know whether it will be proper to write about how on recolonization of Nigeria by Nigeria. Ladies and gentlemen, it all points out that the beautiful ones are not yet born. And today, the words of Ngugi wa Thiong'o still resonate. All those of you who read African Writers series, the Weak Not Child, Nigeria, I believe, will wake up, will rise, will walk, and walk again. I want to specially thank members of my nuclear family. I want to thank Her Excellency, Mama Yerusan. I call her Yerusan, Yarinya Samueli. Thank you very much. And I thank my two prophets, Elijah, Elisha. Many of us know them. TK. They came here when they were just born, and now they are big people. I want to thank my in-laws, Daddy Professor Samuel Ojo, and Mommy Professor Mrs. Titi Ojo of our kingdom. Mama Yesan, Omolofa Majo, Omabi Shujoko, Ijakadi, Katakiti, Loro Ofa. I know the Yoriki of Ofa, in and out, but time will not permit me. Elijah and Elisha, you Omo Ogori Elemosho, Ogomojugun, Ìlú tí wọ́n ti ń jẹ̀ka, kí wọ́n tó mú kọ yangan. Thank you for not minding my excesses and for not stressing me. Ladies and gentlemen, we have talked about the Petrologic Supermarkets. The trajectory of life ends at death and finally terminates in the Petrologic Supermarkets. The whole of this was well captured in Ecclesiastes 2:11 and gives the equation: summation of vanity all over vanity is equal to. So therefore, it is not to him that willeth, not of him that runneth, but of God that showeth mercy. For this God is our God forever and ever. He will be our guide from now, even unto death, when we go back into the Petrologic Supermarket. Here we are today, ladies and gentlemen. We pace hardly at all, yet we have come far already. This is where time transforms into space. And whatever God does is well done. I want to thank the Almighty for what He has done. And I want to thank you for being here. Thank you for listening. And Mr. Vice-Chancellor here, I pause. Thank you, sir.
Please, you can have your seat. Thank you very much for your listening attention. We want to appreciate you. I'm Professor Victor Makinde. I have the singular pleasure to present this award of honor to Professor Victor Makinde as the 95th inaugural lecturer of the university, dated this day, Wednesday, 20th of November, 2024. Thank you very much. Distinguished ladies and gentlemen, I want to appreciate you once again for listening to the 95th inaugural lecture of the university. Before we dispatch, please permit me to appreciate a few people here. Mrs. Adeola Folashade Makinde, you are welcome. Congratulations to you. And I also want to appreciate one of us who has come from a far place, talking about Professor Akinola Akinlabi, the Rector of Oyo State College of Agriculture and Technology. Thank you for joining us, Prof. Of course, I cannot fail to appreciate also one of us, a former Deputy Vice-Chancellor Academic, Professor Catherine Oluyemisi Eromosele, a former DVC. You are welcome, ma'am. And I also want to thank Professor Christian Ikeobi, a former Deputy Vice-Chancellor Academic at the same time. Thank you so much for coming. Of course, I will not fail to also remember a man who has been my employer, Professor Biodun Badmos, former member of the Governing Council of the University and former chairman of FUNAAB. Thank you very much for coming. Distinguished colleagues, members of the University Senate, thank you so much for your listening attention. We really appreciate you. God bless you.
Thank you very much for being part of this 95th inaugural lecture. Please may we rise for FUNAAB anthem.
Tongue may differ in brotherhood.
Thank you very much. Please do remain standing while the academic procession files out of the hall through the center aisle. And for others, the guest of the inaugural lecturer, please you make use of the exit B by my left-hand side. The academic staff, the exit A by my right-hand side. And the non-teaching file out through the center aisle later after the academic procession to the center of the hall, outside the hall there. So we want to appreciate every one of us for being here today to witness the 95th inaugural lecture by Professor Victor Makinde with the title, Beneath the Waves, Resolving Ambiguities in the Petrologic Supermarket. We appreciate you for making time out to be here, and we look forward to seeing you again next time when we host another series of the inaugural lecture of the university. Thank you very much and welcome to FUNAAB.